Hello friends, today we will see another important topic of class 12 physics, that is microscope. There are two types of microscope. One is called as simple microscope, which consists of single lens. Another is compound microscope, which consists of two lenses. One is called as objective lens, another is called as eyepiece lens. Today we will see topic compound microscope, and it have two cases. One, when the final image is formed at a distinct vision, that is least distinct vision, that value is 25 centimeter, represented by capital D. Another case is that when the final image is formed at infinity. So for the first case we will consider case 1, when final image is formed at least distinct vision, that is capital D. Let's see the schematic diagram of compound microscope. Consider one lens. This lens as an objective lens. The principal axis, place one object between focus and optical center of the objective lens. So we know that one parallel light ray passing through the focus of objective lens called as FO. Consider one more ray passing through the optical center of the lens. The two rays will intersect at a point where the final image is formed by objective lens. Consider AB as object, A dash, B dash as the image of the object formed by the objective lens. Draw one more lens. This will act as a eyepiece lens, OE say, and the object is placed at here, so it will act as an object for eyepiece. Let it be UE. This was UO. Distance of object from the objective lens, UO. Image formed will be VO. Distance of image from the objective lens. This will act as an object for eyepiece lens, so the distance is given by UE. Now draw parallel rays from the same point and let's see the intersection to see the final image. If the final image is formed at this point, so draw one more ray which passes through the optical center of the eyepiece lens. This is called as beta. Angle subtended by image on the eyepiece. And then what is alpha? The alpha is considered to be angle subtended by object to the eyepiece, that is I. This is at a distance D, this is AB, this is angle alpha. So as we know that magnification of the compound lens, that is microscope, can be calculated as small m is equal to tan beta upon tan alpha. Angle subtended by image, that is tan beta, angle subtended by object, that is tan alpha, right? Final image is formed at point say A double dash and B double dash. This is the final image of the object placed here. The virtual image of this object is formed at here. So virtual image of any object through a lens, convex lens, is formed only when the object is placed between F and the optical center. So this object is placed between FE, focus of the eyepiece lens, and the optical center OE. So as we know the formula, magnification is equal to tan beta upon tan alpha. We will put the value of beta, this was the beta, and tan alpha, from alpha we can calculate here. So we know that tan beta is from this triangle. We know that perpendicular upon base. So perpendicular is A dash B dash upon the base is A dash OE. So from the figure you can see that OE is nothing but UE, and this is the height of the image. So A dash B dash upon this value is UE. Equation number say 2. We can calculate also tan beta. We had already calculated tan beta. Now tan alpha from this. Tan alpha is equal to perpendicular, that is AB upon, that is distance is capital D. Equation number say 3. Put all those values in equation number 1 to find the magnification. So it can be written as m is equal to tan beta, that is A dash B dash upon UE upon AB upon D. So D will be on the top, UE will be down. So we can also rewrite it as small m is equal to A dash B dash upon AB and D by UE. We know that height of image to the height of object is called as magnification. So this is the image, this one is object. For this is object and this is the image. So which magnification? The magnification of the objective lens. So we can write it instead of A dash B dash upon AB, we can write as MO, called as magnification of the objective lens. And small m is a total magnification of the compound microscope. So D by EU means what? The distance of the image. This is the D, capital D. So we can see that this upon this, distance of image to the distance of object. Again, we are getting magnification. Magnification by which lens? That is called as eyepiece lens. So we can write it as ME. Total, we can see that total magnification of the compound microscope is nothing but the product of magnification of the eyepiece and that of the objective lens. We can also put the values in terms of focal length and distance of the object, right? So this is a basic formula. We can also put the value of MO and ME to find the different formulas. We will see another formula in our next lecture.